Good evening everybody. Welcome to today's session. Today we are going to take up a topic that is called direction sense. So in your examinations you will be faced with certain kinds of questions in which your ability to judge the direction of a moving object or of a moving person will be tested. Okay, so first of all let's understand the basic directions that you will be tested upon. So we'll just make a normal compass. Okay, so we have 8 basic directions. Okay, we'll start off with the 4 basic ones. This is the center, then we have north, we have south, west, and we have east. Okay, so this is the basic compass with the 4 basic directions: north, south, west and east. Now there are 4 intermediate directions over here. So between the north and east we have northeast, between east and south we have southeast, then between north and west we have northwest, and between south and west we have southwest. Okay, so these are the basic directions: north, south, east, west, northeast, southeast, northwest and southwest. These are the directions that you will be tested upon in your examination. Another one is your left and right directions. Okay, so if a person is standing facing this side, then this becomes the person's right and this becomes the person's left. When a person is facing this side, head facing this side, then this will become the left and this will become the right. So it depends which side the person is facing. If it's facing this side up, then this is your left and this is your right. If the person is facing down this side, then the directions are reversed. Okay, this will be your left and this will be your right. The questions will judge you on all these aspects. Okay, so now to understand, let us take a look at a few examples. Okay, we have a question in front of us which says, if I move 5 kilometers to the east. So we'll make a point over here. This will be a starting point. Okay, now I move 5 kilometers to the east. So judging by my compass, east is that side. So I move 5 kilometers that side. Okay, 5 kilometers. And then 12 kilometers north. So move 5 kilometers to the east and then 12 kilometers to the north. How far away am I from the starting point? Okay, so the person started from here, moved 5 kilometers to the east, then took a turn and started moving north and arrived at this point. We are supposed to calculate the distance between these 2 points. So as you can see, we have a triangle in front of us with this being 90 degrees. Okay, because a change in direction east to north is a 90-degree change. So you are supposed to calculate x, that is the shortest distance between the starting point and the ending point. The starting point, the turning point and the ending point. Now if we refer to the Pythagoras theorem, it's a theorem which is used in geometry for finding out sides of a right angle triangle. It says that the hypotenuse square, this is called the hypotenuse of a triangle, this is called the hypotenuse, this is called the base, and this is called the perpendicular. Okay, so this is the base, perpendicular and hypotenuse. So in effect we have a right angle triangle. Now according to the Pythagoras theorem, okay, let me just clear this off. So Pythagoras theorem states that your hypotenuse square is equal to base square plus perpendicular square. Okay, this is a generic equation which is used for solving all problems for right angle triangles. So I will apply this formula. I have to find my hypotenuse, which is x. So this implies that x square, my hypotenuse square, will be, my base is 5 kilometers, so 5 square plus my perpendicular is 12 kilometers plus 12 square. So this implies that hypotenuse square is equal to 5 square is 25, 5 into 5 will give me 25 plus 12 square, 12 into 12, which will give me 144. I'll proceed. This implies that x square equals 169. So to find out x, I will take the square root of 169. Okay, implies that I'll root both sides. X is equal to square root of 169, which is equal to 13 kilometers. So I get my value of x as 13 kilometers. Okay, so I am 13 kilometers away from my starting point. Okay, this is one example of a direction sense question where your ability to calculate or to judge the directions plus your ability to calculate the length of the hypotenuse is tested. Okay, so please keep this formula in mind. It is called the Pythagoras theorem, which implies that the hypotenuse of a triangle, that is the longest side, the square of that is equal to the square of the base plus the square of the perpendicular. Okay, so we can use this formula to find either side. If we are given the value of the base and perpendicular, we can find out the hypotenuse. If we are given the value of the base and the hypotenuse, we can find out the perpendicular. And if we are given the value of the hypotenuse and the perpendicular, we can find out the base. So in this manner, we can solve this sum very easily. Okay, so hope this is clear to you. Let's move right along to our next. Alright, so we have one more question in front of us. It says if I move 8 kilometers to the east, so I'll take a starting point and I move 8 kilometers to the east and then 16 kilometers north. So again a similar question, 8 kilometers to the east and then I move north. (16 kilometers north). The question is, which direction am I in from the starting point? Okay, so I'll refer to my compass. So I have my directions with me: north, south, west, east and northeast, southeast, then northwest and southwest. So I started from a point and I moved east, then I changed direction and I moved north. Okay, so I am in this quadrant. I am in this quadrant, which is represented by the northeast. So my answer is, with respect to this point is in the northeast direction, because this is north, this is east. So between north and east, okay, east and north, between north and east, I bisect it and I get northeast direction. So my answer is the northeast direction. I am in the northeast direction compared to my starting point. Okay, so over here you simply have to tell the direction. You will get sums like this. Let's move along. We'll keep the compass. Okay, one interesting question. A series of turns. In these kind of questions, series of turns will be given to you. So you will have to solve these kind of questions as if you are solving a puzzle. Okay, we'll draw a maze. So a person starts from position A. So let's take this point and mark it position A. Then he goes towards the west. Okay, so we are moving this side. We'll take some more space here. My starting point is A. I move towards the west. And then he takes a left turn. So now you see your judgment of both types of directions is coming into test. East, west, north, south, as well as left, right. Okay. So he moves to the west and then takes a left turn. So if a person is moving this side, he is facing this way. Okay. He is facing this way. When he is facing this way, this is going to be, if a person is facing this way, then this is his right and this is his left. Okay, when you face this way, the top part is your right and the bottom is your left. Similarly, if you are facing this way, the top is your left and the bottom is your right. Okay. Now, in our case, we are moving in this direction. We are moving towards the west and he takes a left turn. Means we'll go down. The person has taken a left turn. So we go down. Okay. Again the person takes a right turn. So now we are moving in the downward direction. We are moving in this direction. Okay. We know that again the person takes a right turn. So when I am moving down, this is my left and this is my right when I am moving down. So left and right keep changing depending on which direction you are moving. So for example, if you are going from home to school, you will have a left and a right. When you are coming back from school, so while going, the things that were on your right will now appear on your left, and while going to school, the things that were on your left will now appear on your right while coming back. So keep in mind, left and right change according to the direction we are moving in. Okay. So again the person takes a right turn. Now he is moving down. So this will be the right. The person takes a right turn and moves, and then again he moves 45 degrees left. So now I am moving in this direction towards the west. So this is my right and this is my left. Okay. So a person moves 45 degrees left. Now if I turn like this, I make a right angle, that is 90 degrees. I am moving half of 90 degrees. So I move like this. And I arrive somewhere over here. I move 45 degrees, okay, to my left. Instead of completely turning, I move 45 degrees. If I extend this plane, this will be 90 degrees. I am moving only half of it. So I turn 45 degrees to my left. In which direction is he from the starting position. In which direction is he from the starting position? So again, I'll refer to my compass and I see that this is my starting position A, this is my ending position E. I have this direction, okay? I am moving downwards and to the west. From here I have come over here. So downwards and to the west means southwest, okay? So my answer will be southwest. With respect to the original position, the starting point A, now I am somewhere in the southwest. I am to the southwest of my original starting position. So this will be my answer. So in these kind of questions, as and when you get information, keep plotting the diagram, okay? And always keep in mind which is your right and which is your left, because right and left keep changing according to the direction that we are moving in. Okay, so to understand this concept better, let us take a look at another example. Okay, our fourth example. A person X is standing at a point. So we take a point and X is standing here. Another person Y is standing to the south of X, facing X. Facing X. So this person Y is standing to the south of X, facing X. So X is facing this side and Y is facing this side. They are facing each other. Y's friend Z. So now this person Y has a friend Z who is standing to the left of Y. This person Z is standing to the left of Y. So when Y is facing upwards, this is his left and this is his right. This is his left towards the west and this is his right towards the east. Okay. So I know that Y's friend Z is standing to the left of Y. Okay. So Z will be here to the left of Y. Z is standing to the left of Y. And X's friend W. So X also has a friend named W. And this friend is standing to the left of X. So X is facing down. X is facing south. So left will be here. And right will be here. Right is towards the west and left is towards the east. Okay. So using this logic, I concur that X's friend W is standing to his left, that is somewhere over here. Okay. W is standing over here. Now the question goes on to say, in which direction is Z standing with respect to W? So considering W as our ground zero, what is the direction of Z compared to W? What is the direction of Z? So I see that if I draw an arrow, W will see Z standing in this manner, okay, down and towards the west. So now when I refer to the compass, down and towards the west means the southwest direction, okay. So southwest. With respect to W, Z is in the southwest direction, okay. So we see that sums will be asked to you where you will be tested on both your abilities to judge the compass directions, north, northeast, east, southeast, south, southwest, west, northwest and north, as well as your ability to distinguish between left and right. Let's take a look at the next question, which is similar to this one and an extension of this one rather. Now in question 4, so in this question, what is the direction of W with respect to Z? So now we change our point of view. First, we were looking at Z from the point of view of W. Now we are looking at W from the point of view of Z. So from the point of view of Z, he will look upwards and towards the east, towards W. Z will look up and towards the east to locate W. So the corresponding direction on my compass is the northeast. So with respect to Z, W is in the northeast direction. Okay. So always keep in mind when the perspectives are interchanged. So when I am finding W with respect to Z, I will get one answer, and when I am finding Z with respect to W, my answer will be completely opposite. Okay. So initially I had found Z with respect to W, so I had moved this side, my answer was southwest. Now I am finding W with respect to Z, so my answer is northeast. This and this are completely opposite. If we see, we have switched both the terms. North becomes south and east becomes west. Okay, so northeast and southwest. So hope this is clear to you. When the perspective interchanges, the direction becomes opposite. Okay, so the position of y with respect to x, the position of y with respect to x is south, and the position of x with respect to y is north. If I see from the point of view of y, if I become y, I will see that x is to my north. And if I put myself in place of x and I look at y, I will find that y is to my south. So when the perspective interchanges, the directions also become opposite. Okay, right. So let's take a look at our next example. Okay, the question says that a man is facing east. Okay, so a man is standing here. A man is standing here facing east. He is facing east. Okay, rather, okay, man is standing facing the eastern direction. At sunrise, where will his shadow be? So always remember sunrise. Another concept to remember, the sun rises in the east. As we all know, the sun rises in the east. So when the sun comes up from here and the rays of the sun fall on a person, the shadow will be in the opposite direction. So at sunrise, the shadow is in the west. At sunrise, the shadow is in the west, because the shadow always falls in the opposite direction from which the rays of light are coming. Similarly, at sunset, the shadow will be towards the east, because the sun sets in the west. So when the rays of light fall from the west, the shadow will be in the opposite direction. So at sunrise, the shadow will be formed in the west, and at sunset, the shadow will be formed in the east. So we see that a man is facing east. He is standing facing the eastern direction. At sunrise, where will his shadow be? So the sun will also rise from the east. Okay, the sun will rise from this side, and the shadows will fall behind him. The shadow will fall over here. This will be the shadow area. So we can say that at sunrise, the shadow will be in the west and behind him. Shadow will be towards the west, and because his face is towards the sun, the shadow will be behind the man. Okay, so to the west and behind him. In the second part of the question, we are asked, if he is facing west, then where will his shadow be? So if the man is facing west, so we have our man over here. He is facing west. The sun sets, or rather, sorry, it is still sunrise only. The sun rises over here in the east. The man is facing this side. So the rays fall on him and the shadow comes here. So the shadow will still be in the west and in front of him. Okay, so whichever direction he faces in, it will not have any impact on the shadow, the direction of the shadow, because the sun still rises in the east. At sunrise, the shadow will always be on the west. The difference is, if he is facing the sun, the shadow will be behind him. If he is facing away from the sun, that is towards the west, his shadow will be in front of him. Okay, so he can see his shadow in front of him. If he is facing the sun, he can't see the shadow, it will be behind him. Okay, so in any case, the shadow will be towards the left. Alright, let's see our next example. Okay, I think we can do away with this now. We are pretty familiar with the directions by now. So again, we have a puzzle kind of a question in front of us. Starting from a point, Venki walked 100 meters north. So Venki is standing over here. Okay, this is the starting position of Venki. He walks 100 meters north. So Venki walks 100 meters north. Then he turns right. So now Venki's, this is his direction. He is facing this side and he is walking. He is facing the north and he is walking. So this is his left and this is his right. Okay, this is his left, this is his right. So what does Venki do? He turns right and walks 100 meters. So he turns right this direction and he walks 100 meters. He again turned right. So now that he is walking towards the east, this is his left and this is his right. Top is left, bottom is right. Okay, so we see that Venki again turns right. Venki again turns right and he walks 100 meters. So again he is turned right and he has walked 100 meters. Then he turned left and walked 50 meters. So now that he is walking towards the south, this is his left and this is his right side. So we see that now Venki turns left and he walks 50 meters. Venki turns left and walks 50 meters. Okay, how far is he now and in which direction from the starting point? So how far is he? We see that he has gone 100 meters top, then 100 meters to the west, to the east. He has come down 100 meters and another 50 meters to the east. So what is the total direction he has walked to the east? This 100 plus this 50, and it is at the same level because he has walked up 100 meters, he has walked down 100 meters. Okay, so he is at the same level. So he is 150 meters away. He is 150 meters away, and in which direction from the starting point? If I look at my compass, he is towards the east. 150 meters east. Okay, so Venki is 150 meters east of his starting point. Okay, this is my end point. The difference is 150 meters and the direction is east. So in this manner you will solve these kind of sums. Alright, let's see our next example. Okay, another similar sort of a question. Okay, our question is, a man walks 40 meters towards south. So this is the starting point of the man. He walks 40 meters towards the south. So he starts walking towards the south 40 meters. Then turning to his left, he walks 60 meters. So when he walks south, this is left, this is right when he is walking south. So he turns towards his left. He turns towards his left and walks 60 meters. Turns left, walks 60 meters. Then turning to his right, he walks 40 meters. Okay. So when I'm moving towards the east, this is my left, this is my right. So now this man turns right and walks 40 meters. Okay. So he turns right again and he walks 40 meters. So I see totally he's walked 80 meters down south so far, 40 plus 40, and 60 meters to the east. Let's proceed. Again turning to his right, he walks 60 meters. So when I move down, this is my left, this is my right. He again turns right and walks 60 meters. Okay. So he turns right and he walks 60 meters. So we see that he's walked 60 meters to the east and 60 meters to the west. So there is no latitudinal change. Okay, it is 0. He is in the same line. Just that 40 plus 40, he is walked 80 meters south. Okay. Our question is, how far is he from his starting point? So I'll say that it is 40 plus 40. That is 80 meters south. This is my answer. 40 plus 40. Okay. There is no left right movement because he's walked 60 meters to the east and balanced it out with 60 meters west. So 80 meters south of his starting point is the current location of the man. Okay. So hopefully these kind of sums are getting clear to you. Once you master your directions, the compass directions, and your sense of left and right, then these kind of sums become very easy. Another point to keep in mind is sunset and sunrise. Okay. At sunrise, the shadow will fall on the west, and whether it is to the left of you, to the right of you, or in front of you or behind you will depend on which direction you are facing. Similarly, at sunset, the shadow will be towards the east. Okay, and whether it is in front of you, behind you, or to your left or right will depend on which direction you are facing. So that is all there is for direction sense. We'll take a look at a couple of more examples to understand the concepts better. So we have a question in front of us. Okay, so Ubud, the town of Ubud is 100 kilometers to the north of Seminyak. So I have the town of Seminyak here, and Ubud is 100 kilometers north. So 100 kilometers north is Ubud. Then Kuta is 90 meters to the east of Seminyak. Seminyak east. So I'll draw this line. This is Kuta. 90 kilometers to the east. Denpasar is 60 kilometers to the west of Ubud. Okay. So from Ubud I'll go west. West by 60 kilometers. And I have the town of Denpasar over here. If Lotto starts from Kuta, so a person called Lotto starts from Kuta and goes to Denpasar, in which direction is he from his starting point? So if I draw an arrow from Kuta to Denpasar, it is in this direction, upwards and towards the west. So upwards and towards the west means this is north, this is west. So my bisection is northwest. Okay. So Lotto is moving in the northwest direction. Okay. By now I hope you are finding all these sums very simple. So we'll take a look at one more example. Okay, Anjali goes for her morning walk at 5 o'clock towards the sun. Okay, so this is the person, Anjali, she goes for a morning walk. She walks towards the sun. In which direction is the sun? It depends on the time. That's why the time is given to you. Okay, 5 o'clock towards the sun, goes for a morning walk. Morning means the sun will be towards the east. Okay, so she starts walking at 5 o'clock towards the east for 4 kilometers. So Anjali walks towards the east 4 kilometers. Then she turns to her left and walks 6 kilometers. So when Anjali is walking to the east, this is her left, this is her right. Okay, so she turns left, that means she turns to the north, and she walks 6 kilometers. So she walks 6 kilometers. Then she again turns to her right and walks 4 kilometers. When she is going north, this will be her left, this will be her right. Okay, so Anjali turns to her right again. Anjali turns to her right and she walks 4 kilometers. So 4 kilometers. Okay. Then finally she turns to her right and walks another 12 kilometers. Again, when she is moving towards the east, this is her left, this is her right. Okay, so she turns towards her right. She turns towards her right, that means she starts moving south. And she walks for a considerable distance of 12 kilometers. In which direction is she moving? Number 1. So she is moving in the south direction now. Okay, she started moving east, then she turned left, that means she started moving north. Then she turned right, that means she started moving east again, and then again she took a right turn, that means she moves to the south now. So she is heading in the south direction. That is the first part of our answer. She is moving in the south direction. Okay, then, and at what distance from her starting point is she standing? Okay, so if you see at what distance, so this is the ending point, we have to find this distance. Okay, so again, if I extend this line up to here, we get a right triangle. Okay, we get a right triangle where AE is the hypotenuse. Either side could be assumed to be the base and the perpendicular. It really doesn't matter. So I'll assume this to be my base and this to be my perpendicular. Okay. Now what is the length of my perpendicular? It is 4 kilometers plus 4 kilometers. Total displacement to the east is 8 kilometers. So my P is equal to 4 plus 4, which is 8 kilometers. And what is my base? The total distance between this point and E is 12 kilometers. Okay, and these 2 points are 6 kilometers. So I'll get, let's call this point X. I'll get XE, that is my base, by doing 12 minus 6. So I'll get 6 kilometers. The entire length is 12 kilometers and this part is 6. So I'll remove 6 from 12. Okay. So I have my answer as 6. Perpendicular of 8 and base of 6. Now I will use my Pythagoras theorem. So hypotenuse square is equal to P square plus B square, which implies that H square is equal to 8 square plus 6 square. So my hypotenuse square is 64 plus 36, which gives me a value of 100. I'll take the square root of 100, which implies that my hypotenuse is equal to root of 100, which is 10 kilometers. So I find the length from A to E is 10 kilometers. So my answer is south, south and 10 kilometers. She is moving in the south direction. Remember, I am not asked the relative position of her current point. Okay, I am not asked her current position with respect to her original position. That is not the question. If that was the question, I would have said southeast, but that is not the question. The question is, in which direction is she moving? So to answer that, she is moving in the south direction now, the absolute direction. And how far away is she from a starting point? I will use Pythagoras theorem to calculate my answer, which comes to 10 kilometers. Okay, so hope this is clear to you. Okay, hopefully these concepts are clear to you. Just to recap, there are 8 basic directions. If we move clockwise, they are north, northeast, east, southeast, south, southwest, west, northwest, and again coming back to north. Then your left and right will vary according to the direction you are facing. And keep in mind, at sunrise the shadow falls in the west, at sunset the shadow falls in the east. So those are the only directions you need to keep in mind. And keep Pythagoras theorem in mind, that hypotenuse, that is the longest side of the right angle triangle, hypotenuse square is equal to base squared plus perpendicular squared. Okay, keep in mind which side is what. The longest side, the diagonal, is called the hypotenuse. Then you have a base and the perpendicular. So in a right angle triangle, this is the perpendicular, this is the base, and this is the hypotenuse. Okay, so the sides which have an angle of 90 degrees are the perpendicular and base, and the other one is the hypotenuse. So just keep these concepts in mind and you should be good to go with your direction sense. So that's all for today's session. If you have any questions, please post them in the comment box below. Please post your questions in the comment box below. Alright, so seems like that is all for today, and hope the concepts are clear to you, and see you in the next video. Thank you.